Settle in. Pull the blanket a little closer. Let your shoulders drop, your jaw unclench, and your breath slow down just a little. You don't have to go anywhere tonight. You don't have to do anything or solve anything or remember anything. Tonight, I'm just going to tell you some things about this beautiful, extraordinary planet you live on. Quiet things, gentle things, the kind of facts that make the world feel bigger and softer at the same time. Because here's something worth knowing before you fall asleep. Earth is not just a rock floating through space. It is alive. It breathes. It hums. It whispers. And most of what it's been doing quietly, patiently, for billions of years, long before any of us arrived and long after we're gone. So tonight, we're going to wander together, through the deep ocean, through ancient forests, beneath the crust of the earth, through the slow swirl of clouds, and all the way up to the edge of the atmosphere where our sky fades into the dark of space. There's nothing to memorize, nothing to worry about. Just close your eyes if you'd like, and let these facts drift over you like water over smooth stone. We'll start where everything started, with the earth itself. Part 1. The earth beneath you. Right now, without you doing a single thing, the ground beneath you is moving. Not dramatically, you won't feel it, but the tectonic plates, the enormous slabs of rock that make up the crust of the earth, are drifting. Slowly, incredibly slowly. Most of them move at about the same speed your fingernails grow. An inch or two per year, depending on where you are. That's not very fast. But when you have millions of years to work with, even an inch a year adds up to something staggering. The Himalayan mountains, those towering, snow-capped peaks you've seen in photographs, are still growing. The Indian subcontinent is slowly pressing northward into Asia, and every year, Everest gets just the tiniest bit taller. Not enough to measure in a lifetime, but it's happening, right now, while you sleep. Beneath all of that, far deeper than any mine or borehole has ever reached, is the inner core of the Earth. It's an iron sphere about the size of the moon, and it's solid, which seems strange, because temperatures down there reach over 5,000 degrees Celsius. Hot enough to vaporize most metals. But the pressure is so immense that the iron can't melt. It stays solid, compressed into a dense crystalline ball at the very center of the world. Around that solid inner core is the outer core, liquid iron and nickel slowly churning. And that churning is responsible for something you probably take for granted: the magnetic field that surrounds our planet. Earth's magnetic field is invisible, but it's one of the reasons life exists here at all. It deflects harmful solar radiation. It catches charged particles from the sun before they can strip away our atmosphere the way they stripped Mars's. It is a silent, invisible shield generated miles beneath your feet right now as you lie here. And here's something almost meditative about that. The magnetic field isn't perfectly still. It wanders. The magnetic North Pole moves around. It's currently drifting towards Siberia at a pace of about 30 to 40 miles per year. Scientists monitor it carefully, and roughly every few 100,000 years, though not on any strict schedule, the poles flip entirely. North becomes south, south becomes north. The last full reversal was about 780,000 years ago. It takes thousands of years to complete. Life goes on. The crust itself, the thin layer of rock you're resting on, makes up only about 1% of Earth's total volume. If the Earth were the size of an apple, the crust would be thinner than the apple's skin. Everything you've ever seen, every mountain, every ocean floor, every canyon and plain and city, exists in that tiny outer skin. And yet within that skin, there is so much. There are rocks that are 4 billion years old, nearly as old as the planet itself. There are crystals the size of school buses growing slowly in underground caves. There is a cave system in Mexico called the Cave of the Crystals, the Cueva de los Cristales, where enormous selenite columns up to 12 meters long have been growing in silence for 500,000 years. in a chamber so hot and humid that a human can only survive inside it for a few minutes at a time. Those crystals grew in complete darkness. No one has ever seen them from inside that cave for more than a brief, carefully monitored visit. They grew for 500,000 years, entirely alone. There is something deeply calming about that. The earth doing its slow, patient work, in the dark, in the quiet, without any audience at all. Deep in the ground, in places you'd never expect, there is also water. Not rivers or lakes. Ancient water, locked in porous rock and deep aquifers, sometimes for millions of years. Some of the water flowing from certain springs fell as rain before the pyramids were built. It soaked into the earth and traveled, slowly, through layers of sandstone and limestone, emerging only now, in this century, into the light. There's a concept geologists use called residence time, how long a water molecule stays in a given place. In the ocean, the average residence time of a water molecule is about 3,200 years. In a deep groundwater aquifer, it might be tens of thousands of years. In a glacier, it can be hundreds of thousands. Every sip of water you've ever taken has been somewhere extraordinary before it reached you. Let that sink in as your breath slows down. The water in your body, in your blood, in your cells, that water is ancient. It has been rain and river and sea and glacier. It has been inside other creatures and inside clouds and locked in ice for epochs. It is borrowed, briefly, and it will continue its journey long after you. That's not sad. That's beautiful. Part 2. The ocean. Now let's go to the water. The ocean covers about 71% of Earth's surface. It contains about 97% of all the water on Earth. And most of it, has never been seen by human eyes. We have better maps of the surface of Mars than we do of the ocean floor. About 20% of the seafloor has been mapped in any meaningful detail. The rest is largely unknown, which means that right now, tonight, in the deep dark of the ocean, things are happening that no human has ever witnessed. The average depth of the ocean is about 3,700 meters. But the Mariana Trench, the deepest known point on Earth, plunges to nearly 11,000 meters. If you placed Mount Everest at the bottom of the Mariana Trench, its peak would still be more than 2 kilometers underwater. At those depths, the pressure is more than 1,000 times what you feel at sea level. It's crushing. And yet, life is there. Strange, soft, bioluminescent life. Creatures that glow in the dark, that navigate total blackness, that have adapted over millions of years to conditions we can barely survive for minutes. More than 80% of the ocean is what scientists call the midnight zone, or deeper, places where no sunlight ever penetrates. Permanent darkness, and the creatures that live there have learned to make their own light. Bioluminescence is one of the ocean's most extraordinary gifts. It has evolved independently more than 40 times in different lineages of marine life. Deep-sea fish with lanterns dangling from their heads. Jellyfish that pulse with cold blue light. Plankton that glow when the water is disturbed, turning ocean waves into something out of a dream. If you've ever seen a nighttime beach where the waves seem to glow, that's bioluminescent plankton. Tiny single-celled organisms called dinoflagellates, flashing blue-green when the water moves. Some beaches in the Maldives, in Puerto Rico, in parts of California, are famous for this. You walk into the surf at night, and every step, every splash, leaves a trail of cold blue light. The ocean is also a keeper of heat. It absorbs more than 90% of the excess heat that our warming atmosphere generates. It has been quietly buffering us, taking in warmth, slowing down what would otherwise be even more dramatic changes. The ocean is patient in ways we are not. Currents move through the ocean like rivers, vast, slow rivers that carry warm water from the equator toward the poles and cold water back. This global conveyor belt, sometimes called the thermohaline circulation, takes about 1,000 years to complete one full cycle. A drop of water entering the current near Greenland might not resurface in the Pacific for a millennium. The ocean also breathes. Not the way you breathe, but through gas exchange at the surface. It takes in carbon dioxide and releases oxygen. Phytoplankton, microscopic plant-like organisms floating near the surface, are responsible for producing about half of all the oxygen on Earth. Half, not the forests. The ocean, those tiny invisible drifters in the sunlit surface waters, are breathing for us and have been for billions of years. Sound travels differently in the ocean than in air, about 4 times faster. Whales take advantage of this. Blue whales, the largest animals on Earth, communicate with calls so low in frequency and so powerful that they can theoretically be heard from one side of an ocean to the other. A blue whale in the Atlantic and a blue whale in the Pacific could, in principle, be in contact. We don't fully know if they are, but the possibility alone is lovely. Blue whales can reach 30 meters in length and weigh as much as 150 metric tons. They are the largest animals known to have ever existed on Earth, bigger than any dinosaur. And they move through the ocean in near silence from our perspective, barely disturbing the surface, singing songs too low for us to hear without instruments. There is a place in the ocean called the SOFAR channel, the sound fixing and ranging channel, a layer of water at a particular depth where sound becomes trapped and can travel extraordinary distances without losing energy. The US Navy used it during the Cold War to listen for submarines. But long before we discovered it, whales had been using it for communication for millions of years. The ocean keeps so many secrets. Some will never be found, and maybe that's all right. Maybe it's enough to know that out there, in the cold dark, enormous gentle creatures are singing to each other across distances we can barely imagine, in a language we still don't understand. Part 3. Forests and Plants. Come up now, out of the deep water. Let's walk into the trees. There are approximately 3 trillion trees on Earth. 3 trillion. That's more than 400 trees for every human being alive. They cover about 30% of the land's surface, and they are doing something extraordinary, collectively, without any plan or coordination. They are keeping us alive. Trees breathe in carbon dioxide and breathe out oxygen. Every deep breath you take contains oxygen that was, at some point, exhaled by a tree or ocean plant. The air in your lungs right now is borrowed from the forest. But trees do more than just exchange gases. They communicate. Beneath every old-growth forest, there is a network of fungal threads, mycorrhizal fungi, connecting the roots of trees to one another. This network has been called the Wood Wide Web. Through it, trees exchange nutrients, water, chemical signals, and even warnings. When one tree in a forest is attacked by insects, it sends chemical signals through the fungal network to neighboring trees. Those trees respond. They start producing bitter tannins or other compounds to make their leaves less appealing before any insects have even reached them. The warning travels through the ground, from root to root. Older trees, sometimes called mother trees by the scientists who study them, seem to preferentially share nutrients with younger trees of the same species, especially their own seedlings. They provide sugars through the fungal network to saplings growing in deep shade, essentially subsidizing the next generation. A mother tree can be connected to hundreds of other trees through the fungal network. When she is dying, she can send a final pulse of carbon and nutrients out to those connections, a kind of inheritance. This isn't sentience the way we understand it. Trees don't think or feel in any way we can recognize. But they respond, they adapt, they share. The forest is a community in a way that goes far deeper than what we see above the soil. Some individual trees are almost incomprehensibly old. The oldest known individual tree, a Great Basin bristlecone pine in California called Methuselah, is over 5,000 years old. It was already ancient when the pyramids at Giza were being built. It is still alive today, its exact location kept secret to protect it from visitors. But even older than individual trees is a grove in Utah called Pando, a quaking aspen colony that shares a single root system. The individual trunks, there are about 47,000 of them, look like separate trees, but they are all genetically identical, all connected underground to the same root mass. That root mass is estimated to be around 80,000 years old. Pando is possibly the oldest living organism on Earth by mass and by age. It has been growing quietly, sending up new trunks and letting old ones fall, since before modern humans left Africa. There is something deeply settling about that. An organism that has been alive for 80,000 years, making no fuss about it, just quietly persisting in the mountains of Utah. Rainforests, which cover only about 6% of Earth's land surface, contain more than 50% of the world's plant and animal species. They are unimaginably complex. In a single hectare of Amazon rainforest, you might find more species of tree than exist in all of North America. The rainforest also makes its own weather. The trees release so much water through transpiration that they generate clouds and rainfall above the canopy. The Amazon rainforest, in particular, creates what scientists call flying rivers, enormous columns of moist air rising from the forest and moving across the continent, delivering rain to places far from the ocean. Without the forest, those regions would be dry. Plants do other things we find almost magical. The Venus flytrap can count, not in any conscious way, but it has a memory of a sort. To trigger its trap, an insect must touch its trigger hairs twice within about 20 seconds. One touch alone doesn't close the trap. The plant waits. If the second touch doesn't come, it resets. If it does come, snap. Sunflowers track the sun. Young sunflowers move their heads east in the morning to face the rising sun and sweep westward through the day, then reset overnight. When they mature and stop growing, they tend to settle facing east, which warms them in the morning, attracting more pollinators. The sensitive plant, Mimosa pudica, closes its leaves when touched. But more than that, it can learn. In a famous experiment, plants were dropped repeatedly from a small height. At first, they closed their leaves in response to the jolt, a defensive reaction. But over time, as the drops continued without causing any harm, the plants stopped closing. They habituated to the stimulus. They stopped reacting to something that turned out to be harmless. That is a primitive form of learning in an organism with no brain, no neurons, no anything we normally associate with memory. The natural world is stranger and more capable than we tend to imagine. Close your eyes and picture a forest at night. The trees standing in darkness. The fungi spreading their threads through the soil. The old roots, miles long, holding the hillside together. The quiet exchange of carbon and water and signal happening all around you, happening right now outside your window, in every park and woodland and hedgerow. The world is full of quiet intelligence. Part 4. Weather in the atmosphere. Above the forest, above the ocean, above the mountains, the atmosphere. Earth's atmosphere is a thin layer of gas clinging to the surface of the planet. It extends to about 10,000 kilometers, but most of it, 99% of the mass, is within about 30 kilometers of the surface. In cosmic terms, it's barely a film. If Earth were a peach, the atmosphere would be thinner than the peach's fuzz. And yet that thin layer of gas makes everything possible. It filters ultraviolet radiation. It holds heat close to the surface. It gives you something to breathe. It carries water from the ocean to the mountains and back again in an endless cycle that has been running for billions of years. The water cycle is one of the most elegant things in nature. Water evaporates from the ocean, rising as invisible vapor into the sky. As it rises and cools, it condenses around tiny particles of dust and salt, forming clouds. Clouds move. They collide with mountains. They cool further, and the water falls as rain or snow. It flows into rivers, soaks into the ground, feeds plants, returns to the sea. And the whole thing starts again. Every raindrop that falls has made this journey many times. The water falling on your roof tonight may have been ocean water off the coast of Africa last month, or snowmelt from the Andes, or the breath of a forest on the other side of the world. Clouds are extraordinary things to think about when you're drifting toward sleep. They look solid, but they're mostly empty space. Tiny droplets of water so small that thousands of them would fit in a single raindrop, suspended in air. A typical cumulus cloud, one of those fluffy, picturesque ones you see on a sunny day, contains about 500,000 kilograms of water. 500,000 kilograms, floating. It floats because the droplets are so tiny and so spread out that their rate of falling is matched by the rising air currents underneath. A cloud is a precarious balance. Thunderstorms are among the most powerful regular events on Earth. At any given moment, there are approximately 2,000 thunderstorms in progress around the world. Lightning strikes the Earth about 100 times every second. That's 8 million times a day. Lightning is hot, about 5 times hotter than the surface of the sun, momentarily. And lightning plays a role in chemistry. The intense heat of a lightning bolt can fuse nitrogen from the air into compounds that fall to Earth and become fertilizer for plants. Lightning feeds the soil. The atmosphere also protects you from space. Every day, Earth is bombarded by hundreds of tons of material from space: dust, pebbles, rocks. Most of it burns up in the atmosphere long before it reaches the ground. You've seen the evidence on clear nights: shooting stars, which are not stars at all, but specks of rock and metal the size of a grain of sand burning up at hundreds of kilometers per second as they hit the upper atmosphere. That faint streak of light you make a wish upon is the last moment of a rock that may have been drifting in space since the solar system formed. The air itself has a smell after rain, that sharp, clean, earthy scent. It has a name: petrichor. It comes from two sources: a compound called geosmin, produced by certain soil bacteria, and oils released by plants. When rain hits dry soil, it releases these molecules in tiny droplets that carry them to your nose. You are smelling life, bacteria and plants signaling the arrival of water. Geosmin. In particular, your nose is extraordinarily sensitive to. Humans can detect it at concentrations of about 5 parts per trillion. We are finely tuned to the smell of rain on Earth. The atmosphere has layers, each with its own character. The troposphere, where weather happens, extends about 12 kilometers up. Above that is the stratosphere, home to the ozone layer, which absorbs UV radiation. Above that, the mesosphere, where most meteors burn up. Above that, the thermosphere, where the air is so thin it barely exists, but temperatures can reach thousands of degrees, though so few molecules are present that you wouldn't feel warmth if you were there. And above that, gradually, the exosphere, and then simply space. The aurora borealis, the northern lights, occur in the thermosphere and above. Charged particles streaming from the sun hit the magnetic field lines that funnel down toward the poles, and as they collide with gas molecules, they release light. Oxygen glows green or red. Nitrogen glows blue or purple. The result is that rippling, curtain-like light show that people travel great distances to see. From space, the auroras look like glowing rings around the poles, vast halos of color circling the top and bottom of the planet. They happen on other planets too. Jupiter has auroras far larger than Earth's entire surface. Saturn has them, even Uranus and Neptune. But Earth's are ours. They have been watched by humans for tens of thousands of years, painted in cave art, woven into mythology, attributed to foxfire and ancestors and gods. And even now, knowing exactly what causes them, they still feel like magic. Let the thought of those lights drift with you. Somewhere right now, in Finland or Alaska or northern Canada, someone is standing in the cold, breath misting, looking up at a sky full of green and violet light. And the Earth is doing it just because it does. The sun and the magnetic field and the gas doing their ancient dance. Part 5. the deep underground. Let's go underground for a while. Caves are some of the most peaceful places on Earth. In a deep cave, far from the entrance, there is no wind, no weather, no seasons. The temperature stays roughly constant year-round, usually somewhere close to the average annual temperature of the region above. In many caves, that means something mild and still, maybe 10 or 15 degrees Celsius, quiet as a held breath. La Chiguila Cave in New Mexico is 222 kilometers long, much of it still unexplored. It was sealed from the outside world for millions of years until modern cavers broke through. Inside, they found formations unlike anything seen before, rare speleothems, crystallized gypsum chandeliers, rooms that no living thing had entered for geological ages. The cave life that develops in permanent darkness is extraordinary. Many cave animals are blind. There's no selective advantage to eyes where there is no light. So over thousands of generations, eyes shrink and disappear. Cave fish, cave salamanders, cave spiders, pale, eyeless, slow-moving, perfectly adapted to a world without light. Some cave species are also extraordinarily long-lived. The olm, a blind cave salamander found in the karst caves of the Western Balkans, is thought to live for up to 100 years. It barely moves. It can go years without eating. Its metabolism is so slow that researchers have observed individual olms staying in exactly the same spot for years at a time. The olm was once thought to be a baby dragon. Medieval Europeans who found them washed out of caves by floodwaters didn't know what to make of this pale, finger-length, limbless creature with a featureless face. They called it Proteus, after the shape-shifting sea god of Greek mythology. Underground rivers carve their own landscapes. Some flow for hundreds of kilometers through solid rock before emerging at a spring. The water that fills these underground rivers has filtered slowly through limestone, becoming exceptionally pure and cold. Many of the world's clearest, most beautiful springs, like the springs that feed the rivers of the Florida Everglades, or the iconic Blue Ice Spring in Albania, are the surface expressions of these underground rivers, the point where the underground world says hello to the sky. Limestone itself is remarkable. It's made almost entirely of the remains of ancient sea creatures, shells, skeletons, coral, compacted and cemented over millions of years. When you walk on limestone, you are walking on a graveyard of the ancient ocean, compressed into rock. The white cliffs of Dover are ancient seabed. The limestone of the Dolomites in Italy is old coral reef. Far deeper than caves, there is a biosphere that most people never think about, the deep subsurface biosphere. Bacteria live in the rock itself, miles underground, in temperatures that should be uninhabitable, in conditions without oxygen or light or any conventional energy source. They metabolize hydrogen produced by chemical reactions between water and rock. They reproduce so slowly that a single generation might take thousands of years. Some scientists estimate that the total mass of life in the deep subsurface may rival the mass of all life on the surface. We have only recently begun to understand this hidden world. The Earth is alive in ways that go far deeper than its surface. Life has found its way into essentially every crack and corner and extreme. From the top of the atmosphere to miles beneath the ocean floor, from scalding hydrothermal vents to frozen Antarctic ice. Life on this planet is extraordinarily stubborn, and you are part of that life. Your atoms were forged in old stars. Your water has been ocean and cloud and river. Your molecules have been soil and sea and air. You are, in the most literal sense, made of this planet. Every piece of you was Earth before it was you, and will be Earth again afterward. That's not a frightening thought. Lie with it for a moment. You are the Earth, briefly, walking around and looking at itself with wonder. Part 6. Earth from above, space and perspective. Now let's go up. All the way up. On December 24, 1968, astronaut William Anders, orbiting the moon aboard Apollo 8, looked out his window and saw the Earth rising over the lunar horizon. He grabbed a camera. The photograph he took, Earthrise, became one of the most reproduced photographs in history. A small blue marble, half in shadow, emerging from behind the gray dead surface of the moon. Seeing the Earth from space changes people. There's a well-documented phenomenon among astronauts called the overview effect, a cognitive shift in awareness that happens when you see the Earth from outside it. The thinness of the atmosphere, the fragility of the thin blue line where the sky ends and space begins, the absence of borders, the smallness of it all, and the beauty. Astronauts come back different. They speak about it with great difficulty. The feeling is described as a kind of overwhelming tenderness, a sudden understanding that all human conflict is happening on this tiny, luminous sphere, and that the sphere itself is impossibly beautiful and impossibly fragile. From space, the ocean is the first thing you notice. Blue, impossibly blue, deeper and richer than any photograph can quite convey. Clouds swirl in slow spirals, typhoons like enormous pinwheels, the white chaos of mid-ocean storm systems, and then vast stretches of clear blue where the weather is quiet. The atmosphere, seen from orbit, is shockingly thin. The astronaut Ron Garan described it as a thin veil, barely there, clinging to the planet. You can see the curvature of the Earth in that thin line of blue at the horizon, the whole envelope of air that sustains all life, visible in a single glance, less than a centimeter thick against the scale of the planet. At night, from orbit, the planet glows. Cities appear as constellations below you, dense clusters of light connected by glowing threads of roads and highways. You can trace coastlines by the lights. You can see the difference between nations by the density of their light. North Korea appears nearly dark beside the blazing illumination of South Korea. The Nile is a thin, bright line through the darkness of the Sahara. Auroras shimmer below you, above you. Actually, once you're in orbit, those halos of green and pink light over the poles. And in the distance, always the distance, the absolute black of space. Unlit, silent, enormous. In that black, the Earth shines. Carl Sagan described it beautifully when speaking about the pale blue dot photograph, a picture of Earth taken by the Voyager 1 spacecraft from 6 billion kilometers away in 1990. In that photograph, Earth is less than a pixel, a tiny speck of light in the immensity of space. From that distance, all of history, all of human achievement, every war and love affair and scientific discovery, every mountain and ocean and forest and glacier exists on that single pixel. The Earth is the only world known so far to harbor life. There is nowhere else, at least not yet found, to which our species could migrate. This is home, and home, from 6 billion kilometers away, is a pale blue dot. But you don't need to go 6 billion kilometers away to appreciate it. You just need a clear night and a quiet mind. The next time you lie on your back outdoors on a clear night and look up at the stars, here is something to hold. You are not looking up. Gravity means there is no up or down in space. You are actually looking out, sideways, or even slightly downward depending on your orientation relative to the galaxy. You are clinging to a spinning ball with your feet, and you are looking out into the universe. And the stars you see are not the night sky, they are other suns. Most of them are far larger than our sun. Many of them are so far away that the light reaching your eyes left them before humans had agriculture. You are looking into deep time as well as deep space. The closest star to our sun, Proxima Centauri, is about 4.2 light-years away. The light you see from it tonight left that star more than 4 years ago. The light from the Andromeda Galaxy, the most distant thing visible to the naked eye, left it 2.5 million years ago. When that light set out on its journey, humans had not yet invented tools. You are looking at the ancient past every time you look at the night sky. And somewhere in the Milky Way, around stars we haven't visited and can barely see, there may be other worlds. There may be other oceans, other forests, other clouds, other lightning, other strange creatures in the dark of other deeps. Or maybe not. Maybe Earth is the only one. Either way, it is astonishing. Right now, you are on a planet orbiting a star. The star is moving through a galaxy. The galaxy is moving through space. Everything is in motion at extraordinary speeds, and yet you feel still. Lying here, covered in blankets, listening to a voice, feeling the mattress beneath you. That stillness is real, and it is borrowed from the universe's extraordinary scale. You are moving at about 30 kilometers per second around the sun. The sun is moving at about 250 kilometers per second around the galactic center. The galaxy itself is hurtling through space at about 600 kilometers per second toward the Great Attractor, a massive concentration of matter hundreds of millions of light years away. And you feel nothing, because everything around you is moving with you. You are inside the motion, like a passenger asleep on a very smooth train. You feel the stillness while the universe rushes on. Sleep, then. You are exactly where you should be. Part 7. Small Wonders. Earth's Quiet Details. Let's come back down now. All the way down. To the small things. A teaspoon of healthy soil contains more living organisms than there are people on Earth. Bacteria, fungi, protozoa, nematodes, mites, a whole civilization, invisible in a pinch of dirt. 1 teaspoon. The topsoil beneath a forest or meadow is alive in a way that is almost impossible to fully comprehend. Those organisms break down dead material and release nutrients. They aerate the soil and allow water to percolate. Without them, plants couldn't grow. Without plants, nothing else could eat. The whole food chain rests on what lives in the ground. Snowflakes are another quiet marvel. Each one is unique, not as a poetic idea, but as a physical fact. A snowflake forms as a water droplet freezes onto a tiny particle of dust, and the ice crystal that forms is shaped by the temperature and humidity at every stage of its journey through the cloud. Because no 2 snowflakes fall exactly the same path through exactly the same microconditions, no 2 are exactly alike. Every snowflake is a record of its own journey. Sand dunes sing. In certain deserts, the Gobi, the Sahara, parts of California, sand dunes produce a low, booming hum when the surface sand slides. The grains are round and smooth from long weathering, and when they move together, they vibrate at a consistent frequency. The sound carries for kilometers. Marco Polo heard it and thought demons were following him. Today, scientists know it is simply the geometry of sand, but knowing doesn't make it less haunting. The color of the sky changes with altitude and atmosphere. At the surface, the sky is blue because the atmosphere scatters blue light more than red. Higher up, it fades to a deeper, darker blue. From the edge of space, it is black with just the thinnest ribbon of blue at the horizon. Sunsets are red because the light travels through more atmosphere at low angles, scattering the blue away and leaving only the warm reds and oranges. If Earth had no atmosphere at all, the sky would be black all day. The sun would be a blazing point in an absolute void. There would be no scattered light, no blue. The horizon would be darkness. The atmosphere gives us the gift of ambient light, the gentle glow that fills a room even when no direct sunlight enters. It's light that has been bounced and scattered so many times that it seems to come from everywhere at once. On a cloudy day, there are no shadows. The light comes from all directions equally. It is one of the softest, most restful kinds of light there is. Fog is another gift. Fog is simply cloud at ground level, water droplets suspended in air, close enough to the ground to touch. Walking through fog is walking through a cloud. Everything becomes soft and distant. Sound muffles. Colors fade to gray-white. Edges disappear. Fog makes the world quiet. In some coastal places, trees, especially redwoods, collect fog. The needles and leaves act as tiny condensers, pulling water from the passing fog and dripping it to the ground. A redwood forest can intercept extraordinary amounts of water this way. In some areas, more than falls as rain. The trees are making their own rain, pulling water from the air. There are places on Earth where it almost never rains, but where life persists entirely on fog. The Atacama Desert on the Pacific coast of South America is one of the driest places on Earth. Some areas go decades without measurable rainfall. Yet certain cacti and lichens and insects live there, surviving on the moisture that drifts in from the ocean on the fog. Life has learned to drink the air. Bees navigate using the sun as a compass, but they can also detect the polarization of light, the direction of light waves, which allows them to navigate on cloudy days when the sun isn't visible. They have a kind of vision we don't share, sensing a quality of light we cannot perceive. Some birds can see magnetic field lines. Migratory birds, robins, warblers, many others, have specialized cells in their eyes containing a protein called cryptochrome, which is sensitive to Earth's magnetic field. They may literally see the magnetic field overlaid on their visual world, a constant compass rendered in color or light intensity that we cannot imagine. There is so much the world contains that we cannot see or hear or sense. So much that other creatures navigate by, live by, that is simply invisible to us. We walk through a world full of signals and fields and frequencies we have no organs to detect. And yet, we are still here, still comfortable, still loved by this planet in its silent, structural way. The planet keeps you warm, warmer than the baseline temperature of a rocky body in our orbit would be because of the atmosphere that traps heat. It filters your radiation. It provides your oxygen. It gives you water in the cycle that never stops. It grows your food from sunlight and soil. It does all of this without being asked, without ceasing, without complaint. You have never had to do anything to deserve any of it. It has simply been given. Closing, drifting to sleep. You've traveled far tonight, down through the crust, past crystal caves and ancient water, to the liquid iron core that holds your compass needle pointing north. Out into the ocean, past the continental shelf and into the midnight zone, where creatures of cold light drift in absolute silence. Into the forest, into the root world and the fungal web, past the mother trees and the ancient aspen whose roots have been alive since before your species left its first continent. Up through the clouds, through the smell of rain and the electric crack of lightning, up past the ozone layer and into the dark edge of space where auroras shimmer without sound, and back down, softly, to a teaspoon of soil and a snowflake and the gentle silence of fog. This is where you live. All of it. Not just the room you're in, but the whole extraordinary, layered, living, patient, ancient system of a planet. You are inside it. It is inside you. Somewhere right now, a blue whale is singing in the deep Atlantic. A forest in the Amazon is breathing out oxygen into the night. A glacier in Greenland is groaning quietly under its own weight. A volcano somewhere is letting out a slow breath of steam. A bat is using sonar in a dark cave. A tree is sending sugar to its seedling through threads of fungus in the soil. The earth doesn't rest, but it doesn't need you to do anything right now. It has its own processes, its own rhythms, its own timescales that stretch into the billions of years. You are welcome to let go. You are welcome to stop tracking the day, stop remembering the tomorrow, stop holding any thought that doesn't want to be held. The planet will keep spinning. The water cycle will keep running. The tectonic plates will keep their slow, patient drift. The stars will wheel overhead as they always have, as they were doing before any human I looked up at them. You have nothing to do right now but breathe. In and out, slow and deep, like the ocean breathing at the surface, like the forest breathing through its leaves. Let your thoughts become like clouds, not pinned, not held, just drifting. If a thought comes, let it pass. If another comes, let it pass too. There is nowhere any of them need to go right now. The Earth is 4.5 billion years old. It has seen the rise and fall of continents, the coming and going of ice ages, the great blossoming of life, and the occasional great dying. It has been struck by asteroids and wrapped in ice and warmed by volcanic skies. And it has persisted, quietly, stubbornly, patiently. And so have you. You have made it through every difficult night so far. Every one. And tonight you are here, warm, resting, letting the planet carry you. Because that is what it does. The ground beneath you, that thin skin on a living planet, sitting in the light of a middle-aged star, is holding you. It has always been holding you. It will hold you tonight. Sleep now. You are safe. You are home. The earth keeps watch.